This question is come from IMO 1961 question 2. Given arbitrary triangle ABC with the sides A, B, and C, let T be the area of the triangle ABC. We are asked to prove the inequality. This is a classical question and they already have many different proofs. Today I'm going to present a proof using cosine rule and some trigonometry identity. I start consider a squared plus b squared plus c squared minus 4 squared 3t. Of course, we hope that later on this expression will be greater than or equal to 0. Okay. So this is a squared plus b squared. Using cosine rule, c squared equals to a squared plus b squared minus 2ab cosine c. And T is the area of triangle ABC, so it is equals to half AB sine C. A squared plus B squared, we have double of it. And for AB, 2AB, and this is cosine C. This will be 2 taken off already, AB taken off. And this is plus square root of sine C. Then we are going to divide 2 here, and times 2 here. Why we want to do that? Because half is cosine 60 degree and square root 3 over 2 is sine 60 degree. So this will become, and this is equals to cosine 60 degree cos 60 degree plus sine 60 degree and sine C. And for this is cos plus sine, and it is cosine 60 degree minus C. Since cosine is not more than 1, and negative of cosine will be at least negative 1. So this will be greater than or equals to 2a squared plus b squared minus 4ab. And for this, take out the 2. We have a squared plus b squared minus 2ab. And this is square of a minus b. Square of a minus c times 2 will be greater than or equals to 0. And now we know that a squared plus b squared plus c squared minus 4 squared 3t greater than or equals to 0, and we have proved the inequality. Again, we need to check when the equality holds. Equality holds if and only if here. Equality holds if and only if c is equal to 60 degree and A equals to B. If C equals to 60 degree and A equals to B, this will mean that actually A, B, and C are all the same. So this is actually meaning that A equals to B equals to C, which means that ABC must be equilateral triangle. So this is the end of this proof using cosine rule and the Trigo identity. Hope you enjoyed it and see you again. Bye bye.